So dear friends, once again welcome. Let us discuss about the Jacobian of the robot. How to get the Jacobian means what is Jacobian? What is Jacobian? And then suppose for 2 degree of freedom, we have 2 degree of freedom robot in 2D. So how to deduce it's a Jacobian? Then what about from this how to relate it with the singularity, or then also you can say what is singularity. So let us discuss firstly what is Jacobian. So Jacobian, what it does, so that we can understand with the help of suppose 2 degree of freedom robot. So suppose the robot, this is a robot inclined with the horizontal axis with theta 1 degree, and then the link to, and this is the and effector effector, and it is of length L1 and length L2. Here this is theta 1 joint here, and suppose you extend it this axis. Which one axis? The link 1 axis you extend, then this angle is then the theta 2. Okay, so it is 2 degree of freedom planar robot. Planar means only 2D. Okay, now we have to know where is our robot. Now our task is what we are going to do. This one we are going to do. So our task is to know where is our robot. Means what? Means we talk about means where is and effector. Okay, so for that we should know, suppose there are x1 x tip, here the robotic x tip and y tip. These are the x tip and y tip, or the coordinates. X tip and y tip are the coordinates of the robot hand, robot or robot tip or and effector. Okay, then what about means how to write, how to get the coordinates. So x tip is equal to what? So firstly the link length of L1, there are 2 links, so that's why L1 and cos theta, means we're talking about this. So there are 2 joints, so this will be what? Means this is theta and it is a L1. So what about its a horizontal and a vertical component? So horizontal components, this one is equal to what? So L1 and cos theta, L1 cos theta 1, and what about the vertical component? So it is L1 sin theta 1. So here x tip is equal to L1 cos theta 1. plus this is for link 1. Link 1. Okay. The same you have to get for link 2. So what will be L2 and cos, then what will be? We are taking measure from the horizontal axis. We are measuring from the horizontal axis. So what about link 2? So link 2 here, theta 2 is what? From the theta 2, I'm going to write here, theta 2 is measured from the axis of the previous link. Okay, if that is measured from horizontal axis, if measured from the x-axis, you can see here x, here y, and this is what? Then this is the absolute frame, absolute coordinate system, or you can say the frame. Okay, or also you can say the fixed coordinate system. So if measured from the absolute frame x-axis, so link 2 is making an angle of theta 1 plus theta 2. You can see here in this figure, this is link 2 is making theta 1 plus theta 2 from the horizontal axis. Okay, so that's why cos theta 1 plus theta 2. Okay, similarly for y, so it is L1 and this is for link 2. So L1 sine theta 1 plus L2 sine theta 1 plus theta 2, and in this way we have two equations. Okay, now we have to differentiate with respect to time. Differentiation with respect to time. Okay, so what we get? D by xt tip divided by dt. So what we get? So minus L1, because a differentiation of cos theta 1 means sine theta 1, and theta 1 is variable, and which going to be differentiated with respect to time, not with respect to the theta. Okay, means theta 1. That's why here again it becomes what? The differentiation of theta, with respect to time, and minus here L2 sine theta 1 plus theta 2 multiplied by d theta 1 plus theta 2 divided by t. So what we get? Minus L1 sine theta 1, and the theta 1 becomes here theta dot, means angular velocity of joint 1, L2 sine theta 1 plus theta 2, and here theta 1 plus theta 2, and dot is here, means angular velocity. Theta 1 here this one is what? So angular velocity of the joint 1. Okay, so similarly we can get, and this is equal to what? Then x dot tip. Similarly we can get y dot tip and it will be L1 cos theta 1, then theta 1 dot plus here L2 cos theta 1 plus theta 2 and theta 1 plus theta 2 with the dot. Yeah, so we have two equations, this one, suppose equation 1 and equation 2, and from this so equations 1 and 2 can be written in the matrix form. So in matrix form, it becomes x dot trip and here y dot trip. So this is matrix is equal to, then here L1 minus L1 sine theta 1 and here minus L2 sine theta 1 plus theta 2. Okay, and so this is the middle matrix, and one more matrix we have to take here, because this is multiplied by what, the theta 1 dot. So here theta 1 dot, and this is multiplied by here equation 2 if you see, or equation 1. Okay, wait, this is for equation 1. So equation 1 if you see, so what we are having, this one, okay, this should be multiplied. So that's why theta 1 plus theta 2 with dot here, and coming back to equation number 2. So this is for equation number 1, and equation number 2 we're talking about this. Okay, so this one means L1 cos theta 1 and here L2 cos theta 1 plus theta 2. Okay, and if we multiply this one, so this is first matrix, then second matrix, then third matrix. Okay, and this second matrix, what is the size of? So it is square matrix, and this matrix is known as the Jacobian. This matrix is known as Jacobian matrix. Okay, so what is Jacobian? See here, so Jacobian is what? Then Jacobian converts rotary motion, means you can see here theta 1 dot, okay, or theta 1 plus theta 2 dot, means these are angular motions, angular velocities. Rotary motion means angular velocity into the translatory motions, means x dot trip here or y dot trip here. Okay, so here you can see here what is the input, what is the output. So our input is what here, our input is this is our input. What is our, this first matrix is our output. Okay, and this middle matrix is our Jacobian. तो Jacobian क्या करता है, angular velocity को linear velocity में convert करता है. So this is the Jacobian. Okay, and what is singularity? So singularity means losing the degrees of freedom. ठीक है, losing the degrees of freedom. ठीक है, और you can see the inverse of Jacobian doesn't exist. ठीक है, so this is in mathematical term, means inverse of Jacobian J inverse 1 doesn't exist. Okay, so if you what we have the Jacobian, ठीक है, and this situation occurs when this situation occurs. So suppose this we have, and this is theta 1, and this is theta 2, and this is the and effector. Okay, so L1 what we have, this is our L1, this is our L2. So either singularity occurs when in case of singularity theta 2 becomes either 0 degree or 180 degree. ठीक है, suppose this robot it becomes theta 2 is equal to 0 degree, then it becomes this one. ठीक है, this is joint 1 theta 1, and this is theta 2, means थीटा 2 क्या हो गया, 0 हो गया. सो L1 L2 आप देख सकते हैं L1 L2 एक ही एक्सिस में आ गया. ठीक है, मीन्स आप एक ही एक्सिस में, मतलब L1 के एक्सिस में, मीन्स इट इज ओनली नाउ कंट्रोल्ड बाय थीटा 1. ठीक है, सो थीटा 1 मीन्स कंट्रोल्ड बाय ओनली वन मोटर. सो ओनली controlled by one joint. One joint means, what is the meaning of this? One joint means one motor. So what is means we lost degree of freedom. Lost degree of 1 degree of freedom. 1 degree of freedom. Okay. So what is the meaning of this? Meaning of this is losing flexibility of the robot. ठीक है, flexibility in the sense of like snake robot. ठीक है, so for that too much flexibility is required for avoiding obstacles. कोई cables है, ठीक है, कोई दूसरा obstacles है, तो उसको avoid करने के लिए flexibility चाहिए robot में. Okay, so it becomes what? आप देख सकते हैं both the links completely क्या हो गया, stressed out, completely stressed out. ठीक है, so it is known as the exterior, the singularity name is here. There are two types of singularity. So exterior boundary singularity, okay. So इसमें क्या होता है, थीटा 2 becomes 0. Okay, now suppose theta 2 becomes 180 degree. Then what happened? Theta 2 becomes 180 degree. Then it overlaps. The both means this one, link 1, okay, and then link 2, it is link 1 and link 2, both overlaps, so here again losing 1 degree of freedom. Okay, so this kind of singularity is known as the interior singularity name is interior, here singularity occurs, and the singularity name is what? So it is, what is happening? It is folded back, completely folded back, and the singularity name is the interior boundary singularity. So in this way we have done, and what the and questions like what is singularity. So singularity which converts the rotary motion into the translatory motion, and this we have explained with the help of 2 degree of freedom robot. In case of 2D means from 2 degree of freedom robot से Jacobian कैसे derive करते हैं. Then the singularity, what is singularity? तो singularity में क्या होता है? Degrees of freedom lose हो जाता है, ठीक है. And it happens when suppose 2 degree of freedom robot है, so theta 2 either becomes 0 degree or 180 degree. So in this way we have done. Thank you.